1. Introduction. AutoRebar is an app that provides Autodesk AutoCAD and all vertical products with an extra toolbar with specific objects for rebar detailing of reinforced concrete structures. There are 4 types of dynamic objects: rebars, marks, calls and the BBs. The rebar objects can be drawn and stretched like polylines and the bar size quickly edited with a double click. Because all AutoRebar entities are graphically connected, the linked marks and calls update automatically at double click. Because all AutoRebar entities are graphically connected, the linked marks and calls update automatically. The user can add a new mark by selecting the rebar to be linked, and double-click it to edit data such as the bar grouping criteria, the bar spacing and the size of the range. Alternatively, normal AutoCAD dimensions can be linked to the mark and used to specify the range of a bundle of bars in the concrete structure to let AutoRebar calculate the total quantity in that range. The great thing is, whenever you modify the concrete shape and stretch the dimension, the total number of bars updates on the fly. The bar Click to load the AutoRebar engine. Click to insert a new rebar. Type 20 for the diameter. Millimeters are the default units for both the model space and the bar diameter. Different units may be selected in the AutoRebar options greater than units. Click a few points to define the vertices of the rebar you want to create. Stretch the rebar to experience the way it reacts. Double-click it to modify the bar diameter, the annotation scale, the display modality, thin, thick or double line, and to hide/show the dimensions. Insert a thread or a coupler at one of the ends. The radius to which the bar is bent is a function of the bar diameter that can be set in AutoRebar options greater than rebar greater than bending radius. By default, AutoRebar adopts the values for the bending criterion defined by Code 2 UNI and the 1st of January 1992 Section 8.3 permissible mandrel diameters for bent bars. Curved rebars. Click the rebar command and specify the bar diameter. Pick a point for the first end of the curved rebar. Type A and pre-center for the arc option. Click on the screen to pick the midpoint and the end point of the arc. Stretch the rebar to experience the way it reacts. Hooked rebars. Start the rebar command and specify the diameter. Pick 2 points to define the straight part of the rebar. Type H and press enter to select the hook option. Type R and press enter to select the right option, or click the right option in the list. Click for the end point of the rebar and press enter to terminate the command. For looped rebars. Start the rebar command and specify the bar diameter. Pick any 2 points to define the first straight section. Type B and press enter to select the bending option. Type 270 and press enter to specify a plus 270 degrees counterclockwise bending angle. Click the screen to place the end point of the rebar and press enter. Five. Polylines to rebars. Draw a polyline. Start the P-rebar command and specify the bar diameter. Select the polyline to be converted into a rebar object.
Six. Stirrups. Draw a 300 mm, wide 450 mm high rectangle. Open the AutoRebar options. Check the Scale 110 option under the Scale tab. Uncheck Draw Local Dimensions option under the Dimensions tab. Start the stirrup command, confirm 10 mm for the bar diameter and 30 mm for the concrete cover. Click the top left corner and the bottom right corner of the rectangle to insert the stirrup in the concrete section. Copy the stirrup outside the concrete section and double-click it. Uncheck the Display Local Dimensions option and change the thickness modality to thin. Seven. Cross ties. Start the sec bar command and specify the bar diameter. Click any point to locate the crosshair on the screen and make a copy a few centimeters apart. Check the options for the active scale and set it to 110. Start the cross tie command and specify the bar diameter for the tie. Specify the bar diameters to be hooked, hook diameter 1 and hook diameter 2, i.e. the 2 crosshairs in this case. Pick the 2 crosshairs to hook the cross tie across them. Eight. Crosshairs. Start the sec bars command and specify the bar diameter. Specify the spacing for the crosshairs and press enter. Pick 2 points to place the array of crosshairs. Stretch the array of crosshairs to see what it does. Because the array has been defined by spacing, the number of bars is increased/decreased to keep the spacing constant. Start the sec bars command again, but this time, after entering the bar diameter, choose the number of bars option, type N or press the arrow. Pick 2 points to place the array of crosshairs. Stretch the array of crosshairs to check what it does. Because this second array has been defined by number of bars, the bar spacing is adjusted to keep the number of crosshairs constant.
Nine. Marks and BBs. Insert any shaped rebar. Open the options and select meters for the range units under the Units tab. That's because while we want to keep drawing in millimeters in the model space, it makes much more sense to enter and read range values using the meter unit. Now go to the Digits tab and select 0.00 from the Range Digits combo box. That way AutoRebar will display the second significant digit for the range, i.e. it will round to the centimeter. Click the Mark command and select the rebar. You may also pre-select the rebar and run the Mark command afterwards. Pick any 2 points to place the mark. From now on these two objects will be linked together and data will be transferred from one to the other so that changes can be tracked in real time. Try to stretch the rebar and see what happens to the mark. Double-click the mark to edit the grouping data. We want this mark to define a group of single bars, placed 200 mm apart along a 10 meters wide range. S equals 200 mm, bar spacing. E equals 10 meters, range along which the bars are placed. That sums up to 10 meters, 200 mm, plus 1 equals 50 plus 1 equals 51 bars. Click OK or press Enter to close the edit form and verify that the marks does show n equals 51 as the total number of bars in the range. Start the BBs command and pick a point to place the bar bending schedule. Double-click the mark again to edit the grouping data. This time we want the mark to refer to a bundle of two double bars, for instance a double bar at the near face and a double bar at the far face, for a total of 4 bars placed, as before, 200 mm apart along a 10 meters wide range. N equals 2, double bars. A equals 1, B equals 1, will show up as 1 plus 1. S equals 200 mm, bar spacing. E equals 10 meters, range along which the bundle of 2 * 1 plus 1 bars are placed. That will sum up to 4 * 10 meters, 200 mm, plus 1, equals 204 bars. Click OK or press Enter to close the edit form and run the BBs command again to update the schedule. The total amount of steel is now 4 times as much. The general formula used by AutoRebar to calculate the number of bars specified by a single mark is as follows. N equals N * A plus B * floor E S plus 1. Where floor x is the largest integer less than or equal to x. Link dimensions. Insert a new rebar and link a mark to it. Edit the mark data and generate the BBs as shown in the previous section. Insert a standard AutoCAD linear dimension, either the _dim_linear or the _dim_align commands will do. The length pointed by this dimension is going to serve as the input value for the range parameter in our mark. Double-click the mark to edit it and click the button to pick the dimension. The mark now shows the field E equals link to the dimension. Click OK to close the form. From now on, this dimension will be dynamically linked to the mark and provide the value for the range parameter. Any change to the dimension will affect the liked mark as well. Stretch the dimension and verify that the number of bars displayed by the mark is modified accordingly. Click to update the bar bending schedule. More on marks. Open a new drawing and insert a U-shaped rebar. Add a mark and link it to the rebar. Edit the mark and insert n equals 5. Leave a 0 spacing and a 0 range. We just want 5 pieces of this rebar. Generate the BBs and verify that it does show a total of 5 bars for the record number 1. Make a copy of this mark and double-click it to edit n equals 3. When an AutoRebar object is copied, it inherits all the links of the original object. This means that the copied mark is also linked to the same rebar and vice versa. Try to stretch the rebar and you'll notice both the rebars to update. Click to update the schedule. Because these two marks share the same mark number and are linked to the same rebar, they add up to the same record in the bending schedule. The BBs now displays a total of 8 bars for the mark number 1. Now copy the mark again, but this time change the mark number from 1 to 2. Leave the n equals 3 field untouched and close the edit form. Update the BBs. Although this new mark is linked to the same rebar, it creates a new record in the schedule because it has a different mark number. Now insert a second rebar, a simple straight bar, or any other shape you may prefer. I will refer to a straight bar for the sake of simplicity. Select the newly created straight rebar and click to add a new mark linked to it. The new mark number is 3 because a mark number 2 is already present in the drawing. Leave the default n equals 1 field. We want this mark to bring just a single instance of this straight bar. Update the BBs. A new record is created for the mark number 3. Now edit mark 3 and change the mark number from 3 to 2. This action will generate a conflict and AutoRebar warns the user with the following message when the BBs command is executed.
Warning, a conflict of mark numbers has been detected. Two marks share the same position N.2 but they refer to different rebars. The duplicate mark has been excluded from the bending schedule. Please resolve the conflict to complete the BBS. Edit the mark again to solve the conflict by changing the mark number, use 5, or any other unused mark number. Update the BBS. A new record is added for the straight bar under the new mark number. By default, AutoRebar starts the mark numbers from 1. This can be changed in options greater than mark data greater than new mark numbers start from n. That can be useful to assign different mark numbers to different parts of a structure. For instance, in a multi-story building, mark numbers 100, 101, 102, for level 1, mark numbers 200, 201, 202, for level 2, mark numbers 300, 301, 302, for level 3, etc.
12. Calls. The call objects are means of inserting references to marks without affecting the bar bending schedule and the quantity takeoff. They are primarily used to insert annotations whose content reflects the mark data. The number of bars displayed by a call are a mere reflection of the linked mark and they do not contribute to the total quantity. Get a drawing with a few rebars and linked marks, generate the BBS and take note of the total number of bars and the total mass. Run the call command to insert a new call, select the mark which the call must be linked to. Pick any 2 points to place the call, select the call and tick the options to display, hide the mark information, repeat the operation for the remaining marks, click to verify that calls are never taken into account by the bar bending schedule. (13) Annotative scales. Select one or more AutoRebar entities. Run the Edit Scale command, type a new value for the scale 20, 50, 100, etc. and press Enter, possibly repeat the above operation to find the best fitting annotation scale. Changing the scale doesn't affect the physical dimensions of the rebars. Only annotations and symbols get scaled to keep the dimension of the characters uniform in the layout, regardless of the layout scale. The Scale tab in the R Options dialog box can be used to specify a new scale for the entities to be drawn. The process of scaling an annotation object goes as follows. 1. First, decide what size that the annotations must assume on paper. For instance, we want the marks and the bar dimensions to be printed 3 mm and 2 mm high respectively. Set this, or any other values in R Options greater than marks, paper text height R Options greater than dimensions, paper text height to. Set the proper units to be used in both the model space and the paper space. For instance, meters are often used for the model space because it is convenient to draft the concrete structure in this unit rather than using millimeters or centimeters to reduce the zeros. On the other hand, millimeters would be the obvious choice for the paper space in the metric system. See also the _PAGESETUP AutoCAD command to set the layout units, while inches would for the imperial system. Inform AutoRebar about your choice. R Options greater than units, model units. R Options greater than units, layout units. 3. Prepare your drawing, possibly using different annotation scales. The annotations will assume different sizes in the model space depending on the scale used for each object. We may use the scale 125 for the general view of a beam, while the scale 110 might be more appropriate for the sections where the stirrups and the crosstees usually involve smaller features. 4. Prepare your layout using the _viewport command. In each viewport, locate the part of the structure you want to represent and run the _zoom alpha xp command, where the alpha parameter is defined by the following formula: alpha equals mu, lu, scale where, mu are the model units, lu are the layout units, scale is the annotation scale used for the objects shown in the viewport. For instance, if we were to adopt meters and millimeters respectively for the model space and the paper space, and create a viewport with annotation objects drawn in a 125 scale, we'd get alpha equals meters, millimeters, 25 equals 1025 equals 40, while a drawing set in imperial units, with the model space in feet, would lead to the following: alpha equals feet, inches, scale equals 12/25 equals 0.48. An arguably faster and more intuitive alternative approach makes use of the annotative scale drop-down menu and the edit scale forms. Here, the mu/lu ratio goes into the paper units field, while the drawing units fields must be filled with the scale parameter. That establishes a direct relationship between the model and the paper space units. Mu/lu paper units equals scale drawing units. The standard edit scale form and the annotative scale drop-down menu become essential tools when using AutoCAD annotative entities, as shown for the section block in the following video.
14. Explode and deliver. As the dynamic objects created with AutoRebar are not visible on a computer where the app is not installed, the possibility to explode dynamic objects into standard AutoCAD entities such as polylines and texts become essential. Run the explode cell command and make a selection with the objects you want to explode. Standard AutoCAD entities such as blocks and polylines included in the selection are not affected by the command. Alternatively, run the explode all command to explode the entire drawing. You'll be prompted to back up a dynamic copy of the drawing that you are going to explode. As before, only AutoRebar objects are affected by the command. Click OK/cancel to save/discard a backup copy of the original drawing containing the dynamic AutoRebar entities. Variable marks. In a tapered structure, rebars must come in bundles with a linearly variable geometry. AutoRebar allows to link a mark to two different rebars which define the starting and the ending geometry within the variable bundle. Run the mark command and select the first rebar. Type B and press Enter/space to select the variable option. Select the second rebar. Pick any 2 points to place the mark. Export to Excel. Get a drawing with a few marks in it. Click the bar list command and save the bar list in your favorite location.